Hey guys, it's Casey and welcome back for part 2 of the tower defense tutorial. So in part 1, we outlined some of the goals that we wanted to achieve while making a tower defense, like what were the core concepts of it, and then we laid out our AI, we made a nav mesh for it to run on, we made, if we go into the folder, so we made the AI runner, so it's just going to be our character, our AI character. We hooked up the AI, so we made our controller, we made our blackboard and our behavior tree. We made a simple task for right when it spawns, for it to run from its spawn point all the way to our end location that we made, and we made a simple, very simple spawner. So we're going to expand upon that code later on, but what I like to do when I start making a game is I like to make out the base functionality of everything. For this, we're going to set up our basic runner, we set up a very basic spawner, we're going to set up some basic towers, and in this video it's going to be specifically setting up a basic tower and a basic projectile. And then once we get kind of the basics of the game laid out and we can hit play and we can see our runner run, we can have our tower shoot at it, it can kill it, if it gets to the end we'll reduce some lives, we'll do that cool stuff first, and then what we do is then we come back and then we build upon that and we grow them to be full-fledged features. So for this being the second video, we're going to do towers and projectiles. So let's go over to our content folder. Let's make a new folder, and the autosave keeps doing this to me lately. Let's rename it, and let's rename it to, let's call it tower. So we have a folder now called tower, and inside of it, I know that I want to now make our tower. For me, I know that it's going to be an actor, it's going to be in our world, it's going to exist, so we know it's going to be an actor class. So if we right click and we do blueprint class, I know it's going to be an actor, I know it's going to exist in our world, we do not need to possess it with AI, we do not need the player to possess it, and it doesn't need to have any type of movement, so it's not a pawn, it's not a character, it's going to be a normal actor. So let's make a new actor, and we will call this Tower BP, just to separate the name from our folder. So with our Tower BP, our new actor now, let's open it up. And the first thing that I want to do is that I want to add some of the visuals to it. So let's add a static mesh. And a static mesh, if you don't know, is kind of, I'm not exactly sure the best way to theoretically explain this, but it's a mesh that doesn't have any type of bones to it. If you have a mesh in the world, a geometry in the world that has bones and stuff, then suddenly it's a skeletal mesh. We don't need bones on our towers. What we can do later is we can have multiple pieces to our tower, and we can have each piece independently rotate independent of each other, but we don't need skeletal meshes for that. If you specifically know in your tower defense you want them to be skeletal meshes, then you will have to set that up slightly differently, but for the most part it would be pretty much the same. But for us, we need a static mesh. Let's call it our tower mesh. And then on the right side, I know we need anything random for this. We're just setting up the basics. So I'm going to type in bush. I'm going to set the tower to be a bush. Look at that lovely bush. And now the one more thing that we want to add for now is that we need to add a way for our tower to target enemies. For me, I know kind of the simplest way of doing it is by doing an overlap box, some overlap collision. You could handle it a few different ways. An overlap collision isn't going to handle all of our targeting logic, and we'll go over that in some of the later videos when we really expand our targeting logic. But for the very basics of it, I believe we can use some collision spheres. I think we can use that. It'll work well for us, at least for now. So let's add a sphere collision, and that what we're going to do is we're not going to worry about really renaming it. But what we need to do is we need to make the radius larger. Remember, this is going to be the aggro range, or the targeting range of our tower. So I'm going to up that to be like 500. I think that's like a pretty good amount. It's going to be pretty big. So in our viewport, we can visualize this sphere. But if I were to save compile it and I was to drop our tower into the world, you could actually see the collision. Oh, but when we hit play, what you'll see is that that collision sphere disappears. We can't see it. So the one thing that I want to do for debug purposes, so that we can test our game a little bit better, I'm going to uncheck hidden in game on our sphere, and that will make it so that if we go back, and now if we hit play, you'll see that sphere, that collision sphere stays there, and we can actually work with it. We can actually see it. So let's hit stop, let's come back, and now what we want to do is we want to run a little bit of code. So let's go into our event graph, and I know that off of this sphere, we want to target our enemies. So with the sphere selected, I'm going to right click, I'm going to do add event for sphere, collision, and add on component begin overlap. So if you watched The video that I made, the first video that I made in the series of the 3 most important kind of concepts for blueprints, we went over a few of the events that we commonly use when making games, and one of them was on overlaps of collision. So here we're going to use that for our sphere, and what this basically says is that whenever anything that matches our collision profiles comes into the sphere, we will get that event to fire. It will say, hey, something walked into my range. So what I mean by collision profiles is that if we click on our sphere here and we scroll down and we see this collision section, what we want to do is we want to drop down this collision presets arrow. And what this does is it shows us all of the collision types that we have. There's 3 types of collision. The first is you just ignore something. It's pretty obvious, right? If we wanted to, we could have our collision sphere just completely just ignore the fact that something exists in our world. It's just going to be like, you don't exist to me, I don't care. Block is the complete opposite of that, and it's saying, hey, this sphere is going to act as a blocker, so that say we wanted to block everything, if our runner tried to run inside of this sphere, it would hit the edge of it and it would be like, whoa, I can't move forward, I'm being blocked. It's literally just like almost like a wall, like it's solidified. We don't want to do that with this collision. What we want to do is we want to overlap. And basically what that says is that we're not going to stop it from entering our sphere, but we're not going to ignore it. We're going to say, hey, something that we recognize has walked inside of it, and that's how our event works. And actually, what we're actually going to do is if we go back to our tower mesh, we don't want any collision on our tower mesh. So what we're actually going to do is we're going to use these collision presets, use the drop down, and do no collision, and then you will suddenly see it still has block on a lot of things, which is interesting. I guess it doesn't matter. I think when you do no collision, it ignores this, and there's just absolutely no collision on it. I thought that would update. I guess it does not. But for this, we don't want our mesh to have any collision. We don't want it to stop projectiles. We don't want it, for tower defense purposes, we just want that to visually be in the world, but we don't want it to actually be blocking things like other towers, and we'll handle logic for stopping towers from spawning later, but for now, we don't want any collision on our tower. So, on that begin overlap of that sphere, what we want to say is, hey, there might be a lot of stuff that enters the sphere. There could be maybe players that walk into this sphere. There could be maybe if you have a complex tower defense that has allied units, they could walk into the aggro range of our tower. Projectiles can enter the aggro range of our tower. So really what we want to do is that when something does come into the sphere and we have an event, we need to say, hey, is that actor that just came into our sphere, is it the AI runner class? So really, if you remember cast, we used it in the previous video, and we said, casting is a lot like asking the game, hey, is this reference that I have, does it belong to a certain class? And here we're asking, hey, is that actor that came in an AI runner? If it is an AI runner, what we want to do is we want to shoot. So before we can really shoot, we need a projectile. So what I'm going to do is I'm going to come back to our tower folder, and I'm going to make a new actor. The reason being is that projectiles are just actors, they're not possessed. While they will move, we don't want to use any type of walking movement. It's just going to be a normal actor, and we will call this our tower projectile. And inside of our tower projectile, we're going to open it up once again. We're going to add a static mesh to it so we can visualize it, and we'll call this our projectile mesh. And on the right side, let's set this to be, let's use a sphere if we can. Let's go to shape sphere. Oh no, I hate the sphere for that reason. The reason why I don't like the sphere is that on the bottom here, the origin of the sphere is not in the center of it. It's offset from the bottom, and I don't really like that. So let's actually see if we can use a cube. Shape cube. Ooh, I still don't like that very much, but we'll use the cube. I think I like the cube a little bit better here. And let's actually scale it down a little bit because it is quite large. So with 0.5, 0.5, 0.5, and what we're going to try and do is we're just going to try and get this center around that origin. This is the default scene root, which means this is the origin of the location of our actor. And if we dragged our projectile to be really offset, while we're moving this projectile in the world, the visuals for our projectile, the static mesh of our projectile, is going to be super offset and wacky. So what we're just going to try and do is we're going to try and get this center on the scene root. If we wanted to, we could promote our static mesh to be the root itself, so it's center. But I normally run into issues when you don't have a default scene root and you make, say, like a mesh or collision the default scene root. Sometimes I don't like that because you lose some functionality like scaling. What ends up happening is if I want to scale this mesh independent of, say, other components inside of here, if it was the default scene root, you wouldn't really be able to do that. You're going to run into some issues, or else you're going to have to do a bunch of extra logic to do so. So generally, I like to keep default scene roots if possible. So we have our mesh set up. This is just going to be our default projectile. We will set the functionality up probably maybe in the next video to make this a bit more complex. But for now, we have our projectile. And like we did with our tower, we need to have a collision component. We need to know that when our projectile hits an enemy, we need to know that it overlapped with the enemy and that we want to do damage to it. So once again, we're going to add a sphere collision. And what we need to do now is that we need to make this sphere slightly larger than our box. I guess we don't necessarily have to make it larger than our box, but I like to do so that the visual kind of matches up a bit better. And what we want to do is, like we did in the tower, we want to go to our static mesh and we want to set it to be no collision. We don't want this to be hitting towers and to be doing wacky stuff. We don't want collision on our projectile. We want it to just be flying through the air, and then on our sphere, we just need to make sure it's set to overlap. So that's all set up. And now what we can do is we can come back into our code. And the first thing I guess we'll set up, no, actually, we'll do the movement first. So one thing that we could be tempted to do is that we could do add component. We're not going to do this, but I'll show you. And we could do projectile movement. Projectile movement is often used for, as it's called, projectiles. Like if you made a bullet in your game, it's very likely that you would use projectile movement so that when your gun shoots, you can throw this projectile across the world at some insane speed. We can have gravity affect it. We can do some cool stuff. But for me, when I think of a tower defense, traditionally I think of a tower that can't really miss. When the tower shoots and that enemy might be running around, we know 100% of the time, at least if there's like no modifiers going on, our projectile is going to heat seek that enemy and it's going to hit him. The issue with normal projectiles is like a gun. When you shoot, your projectile is just going to go in a straight line from where you're aiming. Inside of the projectile movement component, there is homing. However, I really dislike the homing movement inside of it. It's really, I don't know how to describe it. It misses, and essentially you're just going to have like this awkward projectile that's kind of following the actor, and it's like zigzagging back and forth, and half the time it doesn't hit, and it's just super awkward. So what we're going to do is we're going to make our own heat-seeking projectile movement. I have not actually pre-done this code yet. I kind of thought about it before I started the video. I think this is going to work. So what we want to do is we need to make a variable, and we need to call this our target runner. The reason being is that we need to have a reference to who we are actually targeting. After we make it, let's change its variable type to be AI runner. So after we do that, now what we can do later is that when we spawn our projectile, we can tell it who our target is. So inside of our code, we're going to get our target runner, and we want to get his location in the world. So I guess let me back up one little step. I don't want begin play, I want to use event tick, because I know constantly we are going to be setting the location of this projectile in the world while it's heat seeking our actor. So what we want to do now is that we need to come up with how do we do the math to do our location. So I guess if we want to think about the code, I've said this in the other video, as code being a beginning, a middle, and an end. The beginning is what event do we use, the end is our end result, the middle is going to be our calculation. Let's actually set up the beginning and the end first. I know that it's going to be on tick because we need to be setting its location constantly, and I know that, as I said, the end result is that we need to be setting actor location of our projectile. So that's the beginning, that's the end. Now our calculation is all going to be of feeding it a location. So our calculation is going to be, we need to have our target, we need to know the location of our target, and if we know the location of ourself, we can do some math to kind of fill in the middle. So what we can do is we can get the actor location of our target, we can subtract out the location of ourself, and what this represents is that if you watch the part 3 of the important concepts to master in blueprints, it was vector math. And if you remember, if we subtract 2 world space locations of vectors, what it's going to give us is it's going to give us a line. Here it's going to be a line that's facing from our tower towards our runner, and the magnitude of this line is going to be the distance between those 2 actors. Here, we don't need actually the distance of this line. All we need is the direction. So what we want to do is we want to normalize this vector, and that changes its magnitude from some insane number, maybe it's like 800 units away. It's going to make this line be 1 unit long. So we now have a heading, we have a vector that's facing from our tower towards our target, and we normalized it so that it only has a length of 1. And what we can do with vectors that have a length of 1, vectors that are normalized, is that we can multiply them by a float to get an exact length of a line. So here we can actually promote this float to a variable, and we can call this our projectile speed. So now what we have done is we have a line that's facing from our tower to our enemy. We normalized it to be a length of 1, and that we can multiply it by a float. Here, let's make the default value of our float 500 so that it's going to be moving at our target 500 units per tick is what this is actually going to be using. We might change around this code a bit later. We'll have to see, but I'm pretty sure this will work well for us. Now, what we need to do actually is that we need to actually cap this, because I can foresee an issue where, say our projectile is only 200 units away from our target, but our projectile speed is something like 500, we very well might just skip over our target. That could be an issue. So what we actually want to do is we need to cap the projectile speed by the length or the distance away we are from our target. So what we want to do is we want to do min, and what that's going to do is it's going to return the minimum value between A and B. We're going to feed 2 numbers into this, and it's going to select the smaller number. And that what we want to do is that since this is a line between our tower and our enemy with a magnitude of their distance, if we get the length of that line, if we just type in length, we'll get it, vector length, that will be the distance between our 2 actors. So we can say, hey, move our projectile the minimum between either our projectile speed or the distance. So if our speed is larger than the distance away we are, it will be capped at the distance. And then what we can do is we can then take this and that we can add this back into the location of our actor. The reason being is that if we delete this node real quick, this is all relative. If you remember, once again, in part 3 of that video I've been talking about so much, we talked about local space versus world space. When we have this line that represents the distance between 2 actors, it's local. This isn't the world space. Like that line doesn't represent the world space distance. It represents just the distance. It's not exactly a line between the 2 locations, especially when we normalize it. When we normalize a vector, its length is 1. It might be like 1x, 0y, 0z. That's obviously not a world space location. It's local. So that what we need to do is that we need to turn this into a world space location, and that we need to add it back into what it's relative to, and that's going to be relative to the location of our current location of our projectile. And then if we pump that in, this code should be good to go. I haven't tested this code out, so we'll have to see in a second if that works, but I am quite certain that will work for us. So now what we want to do is we want to go back into our tower, and now what we can do is we can say, hey, when our tower overlaps with an enemy, let's spawn our projectile. So what we can do is we can do spawn actor from class. And what we want to do is we want to grab our tower, but there's going to be something interesting, or we want to grab our projectile. So if we grab our tower projectile, you'll see how the only pins we really get here is the transform that we're spawning a projectile at, its collision, and an instigator. There's something interesting we can do is that if we go back to our target runner variable, if we make it instance editable, and that if we expose it on spawn, you'll see that we get something a little interesting, a little cool. What we actually need to do is we need to refresh this, so we're just going to set this back to none, and that we're going to re-punch in tower projectile, and you'll see we have a new pin that's our target runner. You'll see it's exactly that variable. So what we can do is that by exposing it on spawn, what we get is we get the ability to feed it a value for that variable when we spawn it. And what is that variable? It's our AI runner. It just so happens here that we have a reference to our AI runner, so we can punch that in. And then the 2 things that we need to do is we need to give it a transform to spawn. I just want to spawn this at the center of our tower. For now, we can change it around and say we have a tower with like a barrel and we want to spawn it at the end of the barrel. We can set that functionality up later, but once again, I just want to get the kind of the basis of how the game's going to work before we get too deep into things. So what we can do is we can get actor transform of our tower, of self, because we are inside the tower. We can hook up the transform. For collision handling, we want it to always spawn, ignore collisions, Essentially, when you spawn things, the game can check by default. It will check and it'll say, hey, is something in the way of where we're spawning this projectile? If so, don't spawn it. That's by default. What we want to tell it is just always spawn. Don't worry about if we're spawning on top of something. We're not concerned with that. We know we always want to be spawning our bullet when we need to. So I think our code is good to go. So for our tower, when we overlap an enemy, we're going to make sure it is an enemy, and if it is, we're spawning our projectile, and we're feeding our projectile a reference to our target, and inside of our projectile, on tick, we're telling it, hey, go from your current location towards our enemy, and that's what all of our math handles, and it's going to be moving at the speed of our projectile. However, once it gets too close to our enemy, our projectile speed is going to be capped by the distance away we are from our enemy. So let's try this out. I'm actually curious to see if this will work well. So let's actually drag our tower a little bit to the side, and let's actually give it a little bit of distance away. So there we go. So that should work just fine. Now let's see how this works. So we need to hit play, eject, and now let's watch. Do we get a spawn? No, we are not. So let's actually do a little bit of debugging. So oh, actually no, it is. I know what the issue is. Our projectile speed is a bit too fast. If you saw there at the end, I don't know if you saw it, the cube actually was inside of our target. So let's actually move our tower a little bit back. Let's up its projectile, its collision radius. So let's take that sphere that we have. Oops, that's our projectile. If we go to our tower, let's grab our sphere, and let's up the radius for this. Let's make it, instead of 500, let's make it like 1500. So we have that. Now let's go back into our world. Okay, so we have this huge aggro range. That looks good to me. And now the one more thing that we want to do is let's lower the speed of our projectile. So what we can do is we can take this boolean, because once again, our projectile speed, we made a variable. Let's lower that and let's make it about 100. So it'll move 100 units per tick. And honestly, that very well is probably still going to be too fast. We might have to do some extra code here. So let's hit play and let's watch. Our box spawns, and wow, that was very quick. So we might need to actually cap this out. So let's think for a second. We need to make this independent of tick. And how can we do that? Let me think for a small moment here. Because what's happening is that since tick is very, very, very quick, it's very, very, very fast, our projectile is moving very, very fast. What we need to do here is we need to come up with a way to use delta seconds. So let's see here. So what we need to do is that we can actually use simpler math here thinking about it. With delta seconds, there's something that we can do called lerping. However, there is going to be an issue with lerping. I would need to think about this for a second. So with lerping, what we can do, no, it's not lerping. What we want is we need interp. We need constant interp2. And what we have is we have our delta time and we have our delta speed. That is not the right interp. What we need is we need a vector interpolation, and we need a vinterp2 constant. And then what we technically could do here is we could punch in our delta time. We could feed in the current location is the location. If we copy paste this, let's move this code out of the way. So what we could do is we could use the current location of our actor. The target is our enemy, but we're going to have an issue here with our interpolation speed. So what we can do here is we could set that interp speed, let's just set it to 5. So what interp, what it means is it's called, the word interpolation is what that stands for. And the V is vector. So this is vector interpolation to constant. And what this will do is we'll take our current location and we feed it a target location, and then based off of an amount of time, which is our delta time, which that represents, it's a little complex, this is going to be like way wacky. Delta time represents the time since the last tick of the game. So essentially, if you just want to keep it very layman, delta time is a way of making something be independent of tick. Say our game was only running at 10 FPS. Potentially our game is only running at 10 tick. The issue we had before with this code is this was reliant on how much we were ticking. So if our game is running at 60 tick, we were setting its location to be 60 times its projectile speed per second. However, if our game was only running at 10 FPS, our projectile speed was only running at projectile speed times 10 per second. That's an issue. But what interpolation does is we make it independent of tick by using this delta time off of event tick, and that we can make it speed up or slow down based on this interp speed. So I apologize a little bit, but maybe this is helpful for you guys to learn, is that sometimes I do this. I think of some math to do something, I try it out, and while it might work, it's not exactly what we want. We lose some control over it. Here, we lose the control of being independent of tick. Here, what we kind of lose is we kind of lose a really finite control over our projectile speed. But we're actually going to test it out, and we're going to see maybe we can get some of that control back. So let's try our code once again. So with our new math, our projectile, once it's in range, you can see how it's moving towards our enemy. That's awful slow. So what we're actually going to do, let's up that speed. Let's set the interp speed to be 15, and let's see how it looks now. So if we hit play, we hit eject, we back up. Let's see, that's still really, really slow. So I'm a little curious actually why that is so slow. Let's do 150. Let's really pump this up. I'm not exactly sure what that float value on the bottom for speed really represents. I'm not actually really sure. Actually, what that probably represents is that actually we might have really good control here. I'm going to guess that this interpolation speed might actually represent distance. What that kind of looked like is it looked like that cube might have only moved 150 units away from our tower per second. So I'm actually curious. I actually did not know that. If we hook back up our projectile speed of 100, that's actually not what we want. Let's set it back to be 500. So if you remember, in our tower, inside of our sphere, we made that sphere radius to be 1500. So from our tower to the edge over here, that's 1500 units long. If we set our interpolation speed to be 500, I'm curious if this projectile will take 3 seconds to get from our tower to our target. Let's try that out. I did not know that coming into this. 1, 2, 3. That looks like it was about right. While it's a little slower than our target, so it's having a little bit of a hard time catching up to it, that does look like our interp speed represents the change in distance allowed per second. So that's pretty cool. So let's up our projectile speed. Let's change it up to be, let's say 1,000. Let's double it. Let's see if that works a little bit better. So we'll hit play, we'll eject, and now our projectile does a bit better job, and look at that, it hits our target, and you'll see it stays inside of them. What we want to happen is we want our projectile, when it hits our target, to deal some damage. So what we're actually going to do is we're going to delete all this code we did. Bye-bye code. While you did work, you did not work how we wanted you to. So now what we can do is, let's say when our projectile, when this cube hits our target, we're going to use our overlap sphere to deal some damage. So let's grab our sphere, let's right click, let's add an event on collision, on begin overlap, and now what we want to say is that when our projectile is flying through the world, it's going to be colliding with a bunch of stuff, right? It's going to be passing some meshes, it might pass another tower, very well, it might pass through some additional enemies. What I want to know is what I want to happen, because traditionally, when I think of a tower defense, I think of a projectile that homes the target and it only wants to hit its target. That's how I traditionally see a tower defense. If you've played something like balloons, like the monkey defense where you pop balloons, that game is often the opposite, where a lot of that game is it shoots darts, and when it sees a balloon, it will shoot a dart towards that balloon, but there's no guarantee it will hit. That's a little bit different. I'm not really setting it up that way. What I want to do is I want to take our target, and I want to make sure that whatever we're overlapping with, I want to make sure that it is equal. We can check if it's equal by doing equal equal, and I want to make sure it is equal to our target. So here we're saying the actor that we're overlapping with our projectile, is that actor that we're overlapping with, is it equal to our runner? And what we want to do is we want to use a branch for a true-false statement, and if that statement is true, what we want to do is we want to apply some damage to our runner. So what we can do is off of our runner, we can drag off its blue pin, and we can type in the word damage, and you'll see here we have a event called apply damage. Let's use it. So here we'll hook it up on true, and now let's just plug in actually, let's promote this to a boolean or a float. Let's promote that to a variable, our base damage, and we will call this damage. So later on, what we're going to do is we can dynamically set this variable so that at any time when we spawn our projectiles, we can change how much damage it is. But really, what this is doing is just saying, hey, let's apply damage to our actor by this much damage. This is a really convenient node to use. It's built into the game. If we wanted to, we could create a custom event that does the same behavior, but for our purposes, let's just use this generic node. It'll work well for us. And then now what we can do is we can go back and we can go inside of our runner and we can say, hey, now that we're applying damage to you, if we type in damage, we actually have an event called event any damage. And if we read it, it says event when this actor takes any damage. That's pretty useful for us. So now when our projectile hits our enemy and we apply damage to our enemy, we can then have an event inside of our enemy and we can say, hey, when we take any damage, let's just die. Let's just make it so for now our projectile one hits our enemy. So what we can do is that we can do destroy actor. So when we take any damage, let's just destroy our runner. For very basic purposes, let's just have it have some very easy behavior. And what we want to do also is we want to go back to our projectile, and that when our projectile hits our enemy, let's also destroy our projectile. So we need to do destroy actor here also. So if we will run through our logic here, our tower has an overlap sphere. When something walks into that sphere, we have an overlap event. We're making sure that the actor that we're overlapping with is our AI runner. If it is our AI runner, what we're going to do is we're going to spawn our projectile. We're going to spawn it at the location of our tower, and we are going to feed it in a target. We're going to feed it this AI runner. We are feeding it that variable because inside of our projectile, we made a variable called target runner. We made an instance editable, and we exposed it on spawn. On tick of our projectile, it is going to use this interpolation node to heat seek our actor, our target, and then when we get to our target and it overlaps within our sphere, we're going to make sure that it is our target, and if it is our target, we're going to apply damage to our target. We're going to destroy our projectile, and then inside of our runner, when it takes damage, we're also just going to instantly destroy our runner. So let's try that out. So on play, if we hit eject and we zoom out a little bit, we spawn our cube, it heat seeks, and oh, it hit our runner, but we actually did not destroy our runner. So we need to check out why. So if we go into our AI runner, we have event any damage and destroy actor. So here's some debugging to do. I feel like this should be working. So what I'm going to do is I'm going to right click our destroy actor and I'm going to add a breakpoint. A breakpoint is just a way of debugging your game, of finding issues, and what it's going to do is that if this gets called at all, if our game, through its code, it hits this node, our game is going to pause, it's going to bring up the code, and it's going to be like, hey, we're running this code right now. Because I have a feeling that code should be running, but it feels like it's not, so let's try that out. So our projectile flies, hits our enemy, and you can see the game did not stop. This event is not getting fired, so let's try and figure out why. So I'm going to remove that breakpoint for now. Let's go back into our projectile, and in our target runner, we're applying damage, and we're destroying our actor, and inside of our AI runner, we're event any damage. So let's see if we type in damage again, do we have a better event? No, this should be any damage. This should be working. And then inside of our tower projectile, I'm actually curious, are we losing this reference here? So let's actually check that out. So if we add a breakpoint onto our apply damage, what we're going to do is we're going to pause the game when we go to apply this damage. So let's check that out. So we're going to hit play. We're going to let our projectile fly off into the world, and you can see the game paused. We overlapped. It went through this code. We hit this point in our code, and we stopped. So if we check our target runner, that is a reference to our runner. That is right. Our base damage is 0. We never applied a damage. Okay. So there's some learning for you. If you try and use an apply damage node with a damage of 0, it doesn't even try to apply damage. I did not know that. I believe that was the issue there. So let's just up our damage and let's set it to be 1. I believe our code should work just fine now. So if we hit play, we hit eject, and we zoom out, our projectile flies, hits our target, and both of them get destroyed. So there's a little bit of debugging for you. What I like to do when I debug is usually I go to the end of it. That's what I like to at least start with, is I'll go to the end just to verify, because I feel like I know that this wasn't running because it wasn't destroying our actor, but I do like to add that breakpoint. That's my first start, just to double check to make sure it's not running, and that when I know this isn't running, I'm then going to try and find the source of it. For me, we know that we are destroying our cube. When our cube hit our actor, we were hitting this node, so I was feeling pretty confident that this code was running, but then I added the breakpoint here just to make sure we were applying damage, and that if we are running apply damage and we are feeding it the proper reference to our runner, the only other thing it could be is, for me, I know it's just this damage node, because I know that this event any damage is right, so it must have been in here, and if it's not this, it was almost likely to be this. So that was kind of the logic that I ran through there. So let's actually do that one more time and let's talk it through. So in our game, we can at the start spawn a runner. Our runner will run along the mesh, and what we have is we have a tower. When an enemy runs within range of our tower, we spawn our projectile. Our projectile heat seeks our runner. When it hits the runner, it will deal some damage and kill it. So I'd say that was some pretty good results. So that'll be the second video. And what we're going to do in the third video is, I believe we're just going to blow this up. We are going to add a bunch of really interesting functionality, and I'm going to what word was I actually going for there? I'm going to, wow, I don't know what the word I was going for there. I'm going to show you guys how to use data tables. I'm going to introduce, that was the word I was looking for. I'm going to introduce you guys to data tables, and what we're going to do is we're going to make it so that when we create a tower, by the simplest code in the world, it's actually not even code. Really, it's not really code. It's going to be the simplest thing in the world that we're going to set up multiple towers, and we're going to set up multiple projectiles, and we're going to set them up to all have their own unique behavior, and it's going to be the simplest thing in the world to set up. And we're going to use the same blueprints we just made. We're going to handle all of our towers from this tower BP, and we're going to handle all of our projectiles from this projectile BP. It's going to be super simple, and it's going to be really cool. I think really when I show this to newcomers like my friends, it really opened a new world for them. So that'll be the next video. We're going to blow up some of this functionality, and we're going to make our game really customizable, and we're going to make it pretty interesting. So I hope you guys stick around for the next video.